In the last video, we graphed a parabola basically just by looking at what axes we had and based on that finding out what x values are likely to show up. And we got lucky enough that the axes that we happened to have been given showed all of the interesting parts of our parabola. Sometimes we're going to want a little bit more guidance in just what's going to be interesting on the graph of our parabola. It can be helpful when we're trying to plan the graph of any sort of a function to find the x and y intercepts of the graph. Recall, we talked about this for lines. The x-intercepts of a graph are the points where the graph crosses the x-axis. The y-intercepts are where the graph crosses the y-axis. A function is only ever going to have one y-intercept because the y-axis is a vertical line. But it can have more than one x-intercept. To find the y-intercept, we plug in x equals 0 and evaluate. To find the x-intercept, we plug in f of x equals 0. And then typically we have to solve the resulting equation. So as an example, let's find the x and y-intercepts for the graph of a quadratic function. Here we have g of x equals x squared minus x minus 6. When we set x equal to 0, that means we're going to take g of 0 is 0 squared minus 0 minus 6 is negative 6. And so our y-intercept is going to be 0, negative 6. When we set g of x equal to 0, that means we're going to have x squared minus x minus 6 equal to 0. That's a quadratic equation that we need to solve. I think we can solve this by factoring, though. We need two numbers using the shortcut because the leading coefficient is 1. We need two numbers that multiply to negative 6, so one negative and one positive, add up to negative 1, so that'll be negative 3 and positive 2. X minus 3 times x plus 2 is 0, which means one of the factors has to be 0. Either x minus 3 is 0, which happens when x is 3, or x plus 2 is 0, which happens when x is negative 2. So we have two x-intercepts, one at 3, 0, the other one at negative 2, 0. So having found the x and y-intercepts, we have kind of an idea of where we want to draw our graph. We can also use the x-intercepts to help us find the vertex. Our x-intercepts have the same y-coordinate, namely 0, so the axis of symmetry has to be halfway between them. In other words, the axis of symmetry is the line where x is halfway between 3 and negative 2. So 3 plus negative 2 divided by 2, which is 1/2. The axis of symmetry is the vertical line x equals 1/2. And then to find the vertex, we'll take g of 1/2, which is 1/2 squared minus 1/2 minus 6. Now that's going to work out to negative 25 fourths, which is going to be hard to draw. So I'm going to make that a decimal, negative 6.25. Or maybe I want to make that fractional part a fraction. So have a mixed number, negative 6 and 1/4. My vertex is x is 1/2, y is negative 6 and 1/4. Okay, So why do I care about that? Well, that's because that's going to be the turning point on my graph. So I know that my graph is going to go down a little bit below -6. Let's see what else we can do. I also want some more integer points that I can plot. And to get a nice graph, typically I like my graph to go up above the x-axis if there are x-intercepts. So to get a nice graph, I'm going to start with an x value just before the first x-intercept. So I'm going to start at -3. And I'm going to keep going. -2, -1, 0, 1, 2, 3, 4, until I get right up above the second x-intercept. And I know that these 2 points have y-coordinate 2, right? These are the x-intercepts. And I also found the y-coordinate of the point where x is 0. That's -6. For the rest of these points, I'm just going to go through and plug in on my calculator. When x is -3, we'll get +6. When x is -1, we'll get -4. When x is 1, we'll get -6 again. When x is 2, we'll get -4 again. And when x is 4, we'll get +6 again. Okay, so looking at my coordinates here, I'm going to want my x-axis to go from -3 up to 4. And I need my y-axis to go down below -6. I think I'm going to give up on fitting these 2 points and draw my axes something like this. I'm going to put my x-axis kind of at the top of my available space, and I'm going to count out like 9 squares, because then I can have 8 tick marks along the way. And then I'll have x is 4, 3, 2, 1. Leave a space at 0 because that's where my y-axis is going to go. -1, -2, -3. And then I'm going to put my y-axis through 0. And I'm just going to take up the available space. And then above the x-axis, I just have 1. Then I'll have -1, -2, -3, -4, -5, -6. Well, I'll be able to show -6 1/4 here anyway. That's just 1/4 of the way down. So here are my x-intercepts. Here is my y-intercept. I'm going to draw my vertex, and I'm just kind of roughly eyeballing. It'll be halfway across horizontally and 1/4 of the way down vertically. And then I'm going to plot the rest of my points in this table, right? -1, -4, 1, -6, 2, -4. And finally, I'm going to draw my parabola, starting at the vertex, going up through the points I have on the right, and way up above the graph at the end there, up through all the points I have on the left, going way up off the graph on the end here, and there's my graph. All right, so finding the x and y intercept, let me figure out just where I ought to look to find interesting x values.